In that exploration activity that you did after the quiz, you should have discovered some things, some patterns with absolute value equations and transformations, just to make it a little bit easier to graph so we don't have to make tables all the time. So let's review what I hope you learned in that activity. So when we talk about our absolute value equations here, y equals a times the absolute value of x minus h plus k, h on the inside, k on the outside. A, h, and k all affect the graph in very specific ways. And that's what we really want to remember, because these types of transformations happen in all functions that we're going to talk about this year. So they are really good rules to just kind of commit to your memory. So A affects the width, or we call it a vertical stretch. Okay, vertical stretch would change the slope of the right hand and left hand sides of that V shape. Okay, and A can also do super fun things like doesn't want to work. All right, there we go. A vertical reflection. So if that A were negative, it would kind of be an upside down V instead of a opening upwards V. Okay, so A has some power. It changes the slope of the right hand side and left hand side, and also could be a vertical reflection. All right, then we have H, and H can do some pretty powerful things as well. So let's talk about what H does. H is called a horizontal shift. Okay, it's going to change things from left to right. And inside the function, like inside absolute value, is always a horizontal shift, and they're always the kind of opposite of what it looks like. So if we were subtracting 2, we would actually go 2 to the right. If it was adding 2, we'd go 2 to the left. And that's a little backwards. So I always just remember that the horizontal ones are kind of awful. They're backwards from what I think they should be initially. And K out there on the end is called a vertical shift. Okay, it moves things up or down, and vertical shifts are nice. If they're positive 3, you move up 3. If they're negative 3, you move down 3. So the vertical shifts, I think, are easier than the horizontal ones. And the last thing, vertex is pretty important. Like our absolute value functions all have that nice little point where they kind of originate from, and the vertex is going to be that hk value. So if we use that information, let's sketch a very quick graph of our two equations over here. So I'm going to do the parent function in purple. So parent function is just absolute value of x, no changes. It has a vertex of 0, 0, and the slope of the right-hand side is 1. Slope of the left-hand side is the opposite of that, so negative 1. So we have this sort of parent function going on. I should have used a straight line tool. All right. Now we'll graph that other color, or that other function, in a different color. Let's talk about what's going on. Our vertex gets moved to h, which is 2, 3, which is k, so hk. So I'm going to plot that. All right, and hopefully from our stuff off to the right, you noticed that that would be a horizontal shift, 2 to the right and 3 up. So our vertex moved, and our a value, negative 1/2, gives us slope of the right-hand side. So the right-hand side is going to be a negative 1/2. So I'm going to go down 1, right 2, down 1, right 2, to figure out that right-hand side, and the left-hand side just reflects that. So I'm going to go down and left to get those points. Okay, then I'm going to connect them as straight as I possibly can, free-handed again, and there is the transformed absolute value function, negative 0.5 times the absolute value of x minus 2 plus 3. Just using our transformation rules. Okay, let's look at some more, see if we can graph them fairly quickly. So what I would like you to do is list the vertex, and slope of right hand side. RHS, right hand side. Okay, so the vertex in that first one is going to be -4, -1, and slope of the right hand side will be 1. So I'm going to find -4, -1, and slope of the right hand side is a +1, so up 1, right 1, up 1, right 1. Got to get the other side in there too. So your graph should look like that. Super cool. How about the next one? Where's our vertex? Our vertex is at 3, 1. And our slope of the right hand side is -2. So I'm going to find 3, 1, and slope of the right hand side, -2. So I'm going to go down 2, right 1. Remember, slope is rise over run, so we're going to go down and right. And then I can, to find the left hand side, go down and left. All right? So we don't have to create these XY tables every single time. We have some shortcuts now that we're in Big Kid Algebra 2. All right? Vertex on the next one. What do you think? Yeah, 0, 2. Slope of the right hand side, 1/2, +1/2, so it will open up. So I'm going to find 0, 2. Slope of the right hand side, I'm going to go up 1, right 2, up 1, right 2. And then up and left to find the opposite side, connect in the V shape. Okay, last one on this page. Vertex, 1, 3. Slope of the right hand side is -1. So I'm going to find the vertex 1, 3, label our axis, and slope of the right hand side -1. So down 1, right 1, and flip them, so down 1, left 1, down 1, left 1. You get absolute value sketched in like that. Right? Knowing these transformations definitely makes graphing a lot easier. Okay, now we're not asked to graph, we're just asked to describe the changes. So describe the transformations using proper words. So shift, left, right, up, or down, and then it might be a vertical reflection or a stretch or shrink. So the first one in blue, f of x is equal to negative absolute value of x minus 2. We got two things going on. We have this negative out front, and we have this minus 2. Those are the two changes, so those are the two things you get to tell me about. Okay? Any order you can tell me in any order, doesn't really matter. So minus 2 outside, we would say is a vertical shift, and then you have to say up or down. In this case, it's down 2. All right, and then we have that reflection outside. And do you remember what a negative a value did? Yeah, it's a vertical reflection. And vertical reflection, no other information needed there, just a vertical reflection because it flips upside down. Okay, our next one, we have two things going on again. We have this 2/5 and we have a minus 4. So any order, tell me what happens. We're going to shift. It's a horizontal shift because it's inside, right? Horizontal shift. Left or right? Yeah, right 4. And then we have that 2/5 on the outside. Okay, and 2/5 on the outside is going to be a vertical shrink. by 2/5. So it's kind of going to be like we put a weight on top of it and squished it, flattened it out. Okay, so anytime that a value is less than 1, we will have a vertical shrink. And the last one on this page, f of x 10 times the absolute value of x plus 7 plus 3. Now we have 3 things going on, and we just want to talk about them. What do we have going on? So I would talk about this 7 first. Order of operations tells me I would do that. So a 7 plus 7 is going to be horizontal, shift, up or down. Left or right. Left 7. And then I'm going to do something else, right? I'm going to add 3 on the outside, so vertical, shift, up 3, and finally we have this 10 that is a vertical, it's bigger than 1, so it will be a stretch by 10. All right, no graphing necessary, but if you wanted to use a graphing calculator or Desmos, you could totally check those out. Okay, now using just any old function, here we have f of x defined to be this sort of zigzaggy looking thing, and we want to just do some reflections and transformations on it. So a asks us to, we have a plus 3 and a plus 2. So that's telling me I'm going to go left 3, up 2. So I can take my graph and I can just move it left 3, 1, 2, 3, up 2, and there's my new graph. Cool, huh? All right. B down here, I hit a helpful line for myself. I reflected it. Okay, so here is the reflection. Okay, you see it's not exactly the same, but it reflected across that vertical axis. So a vertical reflection, and then we're going to move it, that -1 inside moves it to the right one, so the vertical reflection would have moved it here, and then over 1. Okay. Last one, that didn't line. Last one, 2 times f of x. That's a vertical stretch. So we're going to stretch it by 2. So we're going to make all of our y values twice as tall. So this y value that used to be at 2 is now going to be at 4. This one that used to be at -1 is now at -2. 2 times as tall as 0 is still 0, and this one's -2 stretches down to -4. So all of our y coordinates get multiplied by 2. So if I connect them with a blue line to match, just kidding, I'm just going to stay pink, and then switch to blue, I guess. All right, we get that function right in there. Just stretches everybody out 2 units. And the last thing is writing equations. So we're going to fill in some equations here based on our graphs. So we always want to look for HK, the vertex, and then slope of the right-hand side to be our A value. So vertex in this one labeled number 7 is 0, 0. So we would have, you could write +0 in both of them if you wanted to, or you could leave them blank. And slope of the right-hand side is down 1, right 1, so -1. Okay, and we'll go down. Number 10, we have our vertex here at -2, 0. So h is a -2. Remember, it's x minus h, so this would be +2. And again, if you want to do the vertical reflection and add +0 on the outside, you can. Zeros don't have to be written. Slope of the right-hand side, up 2, right 2. So we have a slope of +1. Again, you could write 1 there or not. 13. Vertex there. So we have a vertex of -2, -3. So we want x plus 2 minus 3 on the outside. Slope looks like up 2, right 2, so a slope of 1, +1. All right, kind of getting the hang of this. Vertex here, 0, -3. So we want x minus 0 and a -3 on the outside for our vertical shift. And then slope of the right-hand side. Try and find some that line up nicely with grid marks. So 1, 2, 3, 4 up, 2 to the right. That sounds like a slope of 2. And it does look narrower, so that makes sense. It's a vertical stretch. Last couple. See if you can do them on your own before I get them done. Did you get that for 14? Good job. So, 2, 3. And slope of this side. Looks like a slope of -2 there, I think. All right, do we agree? Or did I make a mistake? Let me know if I made any mistakes. I hope this helps you figure out absolute values or kind of bring together that activity from yesterday. If you have any